We're going to do another example of graphing here. So we have a cubic, and we're going to first find where the function is increasing and decreasing. So to do that, we need the first derivative. So we'll say f prime of x is going to be 3x squared. And then we'll go minus 2 times 1.5 is 3x, and minus 6. So there's our first derivative. We're going to set it equal to 0 to look for critical points. We can divide everything through by 3, so that'll become x squared minus x minus 6, which is more factor friendly. And if we factor that, I think we get x minus 3, x plus 2, which is going to make 3 and negative 2 our critical points. We are going to do our number line. So here's our f prime number line. And we're going to put negative 2 there, positive 3 there. If we put in something to the left of negative 2, like negative 3, these will both be negative. They'll multiply to be positive. If we plug in something in the middle region, like 0, we'll get a negative and a positive, which will multiply to be negative. If we plug in something to the right of 3, like 4, both factors become positive, and their product is positive. So now we can answer the questions to part A. We can say that f is increasing on the interval where the derivative is positive, so from negative infinity to negative 2, including the negative 2, and from 3 to positive infinity, including the 3. The original function is decreasing when the derivative is negative, so that's going to be from negative 2 to positive 3. We can look for relative extrema. Since the derivative goes from positive to negative at negative 2, that's going to make us have a relative maximum there. So that's at negative 2 comma. And now we got to plug negative 2 back into the original. So negative 2 cubed is 8. Negative 2 squared is 4. Times 1.5 is going to be, I think, a negative 6. Negative 6 times a negative 2 is a 12 plus 2. So I think that's 2 plus 12 is 14 plus 2 is 16, I believe, is going to be our relative mass. It needs to justify that, so we will say this is a relative maximum because f prime changes from positive to negative. We can see that the derivative goes from negative to positive at 3, so we will have a relative minimum at 3 comma. Now let's see if we can do this arithmetic. 3 cubed is 27. 3 squared is 9. 9 times 15 is, let's see, 9 times 10 is 90. And 45 is 135, so I think that's 13.5. And negative 6 times 3 is a minus 18 plus 2. So let's see, 27 and 2 is 29. 29 minus 18 is 11. 11 and negative 13.5 is going to be, I think, a negative 2.5. Then we can look at the second derivative. So I'll change color for that one. So here's our f prime. So f double prime is going to be 6x minus 3. And if we set that equal to 0 to find our potential inflection points, I think we'll get only x equals a half. So if we do our number line, and I'm going to kind of write it, I like to write them kind of underneath each other, so f prime and f double prime, and 1/2 is going to be somewhere in there. And we can see to the left, if we plug in 0, we'll get a negative, and if we plug in something bigger than a half, like 1, we'll get a positive. So we are going to get for part C that it is going to be concave down. The original function will be concave down from negative infinity to positive 1/2, and it will be concave up from 1/2 to infinity. So that means part D, we have an inflection point at 1/2, and oh yuck, gonna have to plug in 1/2 into our function here. Yikes. So let's see what we can do with that. So 1/2, let's see, 1/2 cubed is going to be 1/8. We're going to get minus, I'm going to call that 3/2 times 1/2 squared is 1/4. Minus 3 plus 2. So that's 1/8 minus 3/8. 1/8 minus 3/8 is negative 2/8, which is negative 1/4. And negative 1/4, let's see, the negative 3 plus 2 is negative 1. So a negative 1/4 minus 1 is negative 1 and 1/4. So there is our inflection point. All right, see if we can put it all together into a nice graph, or even a not so nice graph. We'll see how that goes. So let's see, we'll go with yellow. I think we've got a relative maximum at negative 2 and 16, which I'm going to arbitrarily call there. And a relative minimum at 3, 1, 2, 3, to negative 2.5, which I'm going to arbitrarily call there. We've got an inflection point at 1/2, negative 1/4. 1/2, negative 1/4 is going to be right about there. And then let's see what we got. It's going to be increasing all the way to negative 2, and it's going to be concave down all the way through there. So increasing and concave down. Then it's going to decrease and be concave down until we get to 1/2. Then it's going to continue decreasing, but be concave up. And then it's going to increase and be concave up. Okay, I think that's the end of our story.